Bienvenidos a la sesión vespertina de nuestro Congreso y vamos a continuar con nuestro programa en donde tenemos la conferencia magistral titulada A Review of the Effectiveness of Some Asian Mangrove Restoration Initiatives, que va a dictar el doctor Muthusankar, de quien me voy a permitir leer su reseña curricular. Thank you very much, Doctor, for accepting the invitation to be in this conference and visit our country. Bien, el doctor Muthusankar es investigador y jefe de proyecto SIC en el Departamento de Vigilancia Geoespacial y Tecnología de la Información GeoSmith del Instituto Francés de Pondicherry. Cuenta con alrededor de 20 años de experiencia en el campo de investigaciones de teledetección y los SIC para la vigilancia del medio ambiente. Ha publicado más de 50 trabajos de investigación. Su campo de investigación se centra principalmente en la evaluación de los riesgos y vulnerabilidades medioambientales frente a los peligros naturales relacionados con el clima, el cambio climático y el aumento del nivel del mar, las fuerzas oceánicas y los efectos antropogénicos mediante observaciones espaciales y datos de campo. Cuenta con numerosas colaboraciones de investigación a escala nacional e internacional en el campo de la restauración de manglares en países tropicales. El doctor Muthusankar cursó estudios de maestría en geología, maestría en tecnología y doctorado en teledetección en la Universidad Bharathinsan de Tiruchirappalli, India. Muchísimas gracias. Thank you, doctor. Vamos a darle un fuerte aplauso para darle oportunidad que continúe. Go ahead.
Thank you, Doctor, for your nice welcome address. Thank you. Thanks. First of all, I thanks to organizer to giving this. I'm very much pleasure to hear. So, I'm taking here a review of the effectiveness of some Asian mangrove restoration initiatives. Actually, French Institute is in India. We have a lot of working involvement in the European Union projects. So we are working entire world. We are working. So many projects. So here I taken different project that is synthesis to this work. I synthesize this work. I taken 4 sites for your case study. I taken here. I will tell you all this. It's a teamwork. There is a institution from the France also is involved. Then Sri Lanka University involved. And then IRD is IIT AMAP is a big research organization in France. Their researchers also are involved in this project. We will see one by one in this. Okay. Yes. Yeah. Mangrove forest is one of the unique forest, unique ecosystem. Is the intertidal zone. Only is presented in the trophic region only. It's a highly resource place. Up to 90, there is a destroyed happen. Nearly 1% every year in the cover 1% happen. And we don't know the value of the mangrove. We thought normal terrestrial forest like that, but it's highly resource. Yeah, it's okay. Highly resourced resource area. Biodiversity wise, rich place in mangrove area. Both fauna and flora is highly there. This is a fish nesting place. This is one of the unique ecosystem mangrove forest. So afterwards, we are then the carbon storage, capacity of carbon storage is more in the mangrove area. So slowly we started to restoration process. First conservation, because afterwards only we declare a lot of the reserve protected area mangroves. After 90 only we will a lot of mangrove forest. We announced the protected area. Then we conserve the mangrove region. Afterwards some restoration also happened. And because at that time they converted mostly in the aquacultures and urban expansion development. We destroyed the mangroves. Now we have the good knowledge for the mangrove forest. So we are starting to restoration and replantation, all we are doing. We'll see one way. Okay, in this talk objective, I evaluate effectiveness of restore mangroves. This study compares state of art of the mangrove restoration with the evaluation of 4 selected places. I taken here South and Southeast Asian country. Study area, Philippines. I taken the Philippines zone study area. Then another one in Indonesia. It's all our project went in this region. So all the project last 5 years we went to the project in these places. Then Sri Lanka also. Then one more in Pichavaram, India. So Pichavaram mangroves. So 4 sites I taken for the case studies for this study. Yeah, first Philippines. I think most of the people know it is highly vulnerable to the typhoon, hurricane. So hurricane is, see, typhoon frequency. Last 20 years, from 1980, within the 100 kilometers, too many typhoon strikes in this. That's why there is a lot of funding agency giving the project to the Philippines to bioshield program to mangrove restoration program is going there. That type of one program, French funding agency, one given to the one NGO, to the Philippines NGO for green grey infrastructure project. They provided the funding. For our assessment to evaluate that project has happened 2015 to 20, pandemic time they extended 2 more years. So 15 to 22 the projects happen, no NGOs. For that funding agency assigned to us to evaluate in the ground how they implemented the project. So that purpose only we went there and we evaluate their restoration project. Okay, this is that province name is this is the Philippines. Conception, province name is Conception. This is the south of the Philippines area. So this is all 5 sites, nearly 7 sites. Their the restoration projects they did. That the green and grey infrastructure, the new implementation they did here. I will see what is the green and grey infrastructure. Just see. They just they construct the breakwaters using the stones or bamboos. Using the stone or bamboos, they construct the breakwater. Then they sediment traps. On that sediment, they replanted the mangroves. This is the right position. See here, one site they selected the site. Here they made it bamboo breaker. They model this one. See, this is a see in the field, bamboo they did, the bamboo breaker there, no? But that bamboo, it's a sediment, it will fill there, the sediment is filled in the front. Then this is the bamboo one. Another one is they used stones for the breakwater. They used the stone, they did the model like that. Once did the breakwater, then the sediments trapped there in front of that breakwater, they seed the they planted the mangroves there. Okay. Yeah, this is all. They're all what they did in this one. Here is a high water time. Back in this image is high water time. So all the plantation is there. The plantation there. They did. So that is okay. Yeah. See here. Once the breakwater ready, the sedimentation in front of the sedimentation is trapped in this stuff. They planted. Then the another one they telling is living breakwater. Because there is oysters are there in the rocks. Oysters there. The people are collecting the oysters there. This one. So living. That's why they are calling living breakwater in this one. Oysters collecting. Okay. Yeah. The different places. Because 5 sites. I am showing this what they implemented the project. This. Okay, so this is a 5 site. Okay, they did the number of plants. The number of plants is each site based on the site. There is nearly 20 hectares. All the area, totally 20 hectares. They restored this area. The planted species, different species they used. Avicennia, Rhizophora, then Avicennia, Rhizophora, Microhydra, different species also. And then grey structures, depends upon the places. They use the bamboo structure or stone structure they used. Then same time, livelihood program also, they did the livelihood program. So, some tailoring training, given the tailoring training, then dry fish plant, then kaya, making the kaya plant, all they given the livelihood program also. Then awareness program also, because the mangroves are very helpful for the cyclone time. Cyclone time, this is a bioshield. So they give the awareness program also, in this all is there. Okay, so we went for the evaluation purpose. We went. After they are finishing, their project was finished, we went there. The problem afterwards, yeah, you can see the sediments is trapped, but the mangrove survival is less only. Mangrove plant survival is less only. Because I will tell the why reason also, I will see. This is a scenario, you see. Then another poor condition, they kept all the plastic bags in one place. All the plastic they kept all this one. This is area. All the propagules. See, we did the transect. Each survey site places we did the transect, and number of plants we counted in this transect. We see. Same time we questioned the people also. Yeah, backside is our daily field trip boat. Nearly 1 week we use this one. So like that we evaluate entire, we taken all the transect, how many plants are surviving, all we taken the statistics, all we taken, all the things we taken. Just you can see. Same time we worked for the research purpose, we worked using the sentinel data. Before starting the entire study, 2017 data. So we taken using that sentinel data, is a 10-meter resolution satellite data. So we used mangrove cover, how much cover, entire study site, then restoration site, how much. Then 2022, entire study area, restoration area. Here is have this one, entire study area, normally natural mangrove is more. Even the restoration is that's even restoration places also. Yeah, that's why the image you can see, both the outer ring is the entire study site, and the inner ring is the restoration places, mangrove is one. So survival is more natural area, even the restoration. That is my coming to the grey infrastructure. How is it? Some places quite good, because in the hard structure, the stone place is good, but the bamboo is cyclone time is all the bamboos are destroyed. Because we went not that much results given, but this stone structure is good. That many lot of sediments deposited. Each site-wise we taken the fine texture, observe the deposit, then ecological restoration. All we taken. This is the status of the each sites. Okay. Then that I already told transect we did, and that transect based on the transect you can see the results. The ratio is the survival ratio is very less only. Okay. So overall observation in this one, reforestation projects have failed. The project leaders choose the improper reforestation site. Then between the time reforestation and the young mangrove were partially destroyed because of the die wood. Then because often is coming once planted, they destroyed this. So the main reason here, proper site is improper site selection, then improper species also. Whatever is available, the type mangroves, small young plants, propagules, they seeded, they planted. That is also one of the problem in this one. So this is first case study. So yeah, this is now we are submitted this paper under the review in this one, in the coast. We submitted the paper. So next case study, this is one of the abundant aquacultural pond. There they planting the mangrove in Indonesia, Poly area, abundant aquacultural field. So they planting the mangrove here. This is a site selection, site study area. This map. So we used very high resolution image from 2001 to 2015. We taken nearly 15 years high resolution satellite images we taken here. So why very high resolution image? You see, if with the high resolution image, we see all the mangrove species up to species wise. If you use the even 6 meter resolution, last one is not that much good. 6 meter resolution. If you use the high resolution 50 centimeter one, it's good. Up to each plant wise is possible to map. I will show you next. Yeah, this is the methodology we did. One side we did the image processing, another side we taken the ground truth also. Because every pond walls, pond floor, the natural other surrounding natural area, all the area we did image processing, and what is the we mapped the land use land cover of that area, mangroves area. See here the one example, natural mangroves planted. Before the planted 2014, before planted one small natural mangrove is there. Afterwards planted one. The B image is after the planted one. Then here see the planted, even the natural one is good healthy. See the good healthy. The planted one, all the maximum they used mono one only rhizophora only they planted there. But that place is, yeah, I'll show you. Yeah, here the comparison, just natural area, pond floors, pond walls. Same here, natural one and then planted one also. So the natural elsewhere, all the places. So here see, planted is a black one, and then blue one is a ponded floors. So the natural one is good. Even the pond wall also, other places, all is good as one. Here see, from 15 years, all the maps we did. So here the fraction also, mangrove fraction, low is less than 5, low is 3 dotted. 3 dotted in the 3 dotted one. Coloring is year-wise they planted. Coloring index is year-wise planted. Then the dotted line is showing the fraction cover index. Low is 3 dotted, then line is 50 to 90%. Full is a full green filled color. So this is the status after this one. So we did the planted area and natural area also. As the dotted line is planted area, green one is the natural area. It's showing good in the natural area. So then the species wise also, we get all the AO, Avicennia marina, Avicennia officina, we used all the species wise also. The see results, mangrove, the natural one is giving the good results. Even the rhizophora is not, the colonization also not that much level. Natural is the good results, given the good results here is. Okay, this is one case study. This is already published in this paper in the Marine Pollution Journal. Then we taken the third site. This is actually a different project. That is, this project is Fisherman Wellbeing Project. It's a European Union funded project. Fisher Coast. Project name is Fisher Coast. That's a Fisherman Wellbeing. That project we did this type of work also. So south area, down south area in India, Pichavaram mangroves. Okay. So we did the mangrove habitat extent, mangrove diversity, mangrove health, then the efficacy of restoration attempts, how all we did it. Then we did the higher resolution. Here also we used higher resolution image only, 2003 to 19, then field collection, monsoon, pre-monsoon we taken, then tree height, crown size, salinity, all the data we taken. Okay, just, yeah. We will, the different thread, we will see the different thread. There is a hydrological alteration. Now the problem is from the seawater, sea level rise, seawater intruded from the river, inside the seawater intruded to inside. That's why in the PWTA people, what they are doing, they constructed the check dams here. So now is for the agriculture purpose, otherwise the seawater will going inside. So the entire area is salinization. Then the agriculture people protest. So they made the check dam here in this place. So now the freshwater flow is stopped. to the going to the creek in this one. So it's happened two places. This is one right. Another one they made for the plantation purpose, fish pond, actually good method. But here I will show you how they did. First, it will work only. But what they did, everywhere they did the fish pond method. All the places they did this one. Well, problem increasing the salt water is increased, you know, because the salt pan area also they did the fish pond method. They changed the hydrological this one flow. See here, here is the another problem. One side is outside, inside the land, development of aquaculture all are happening in this region. See the 2005 image and 2018 image. Another side is shoreline erosion is happening because of this, there is that already, this is also cyclone prone area only, cyclone and tsunami happen here only, the erosion is happening that side. Then another now is new problem here in the south of this area, they constructed the breakwater for harbor, they constructed, fishing harbor they constructed. So that also is giving the erosion in the north of the breakwater. So totally now eroding, one side is threatened, this side is development threatened. Then we taken two sentinel, land use land, two sentinel data, 2016 and 19 data, 10 meter resolution. Then we taken high resolution from 2005 to 2019, 2003 data, 5 data, 11 data, 16 data, 2019 data. We purchased in the very high resolution image we purchased. So we did all the analysis. You see here the low resolution image and high resolution image information. Of course, high resolution is too costly also. The project is European Union funded project, that's why we bought all the things. Then we taken the water sample also from this one, just salinity control. Less than, blue color is less than 30 ppt, red color is greater than 30. So, see, all is salinization more, full entire region in this one. So, we collected the electrical conductivity EC, then TDS, resistivity, salinity, dissolved one. Then the ecological parameters also, DBH, cannabinoid, species, all the species also we recorded in this area. We did the change analysis also in this region. We taken fully in this region. Mangrove, non-mangrove area we did in this one. Okay, then here is the interesting. That one, the black color is total mangrove growth year-wise, 2003 to 2019. Then natural mangrove variation from 2003. Then artificial one, green one. This one, artificial means planted one. So we taking all this scenario. So this is the changes, overall changes is one. Mangrove, non-mangrove area, total one this, up to this one. Here we change cover analysis, we did the fish pond area, natural area also. See, I think it's dotted line is fish pond area, then the natural area, the total we did. Same time, net gain, loss also, we did the analysis also. Yeah, observation, yeah. So, mortality of rhizophora trees in this area, because of the salinization more, there is a lot of mortalities happen. See that yellow color, that place is yellow color, whatever, I think the indicator is not, yeah, this, see, this is all apparent in diebacks is one. So unsuccessful fish pond is one, then aquaculture also. We don't know the reason because we need to lot of analysis, then only we get the answer. See the field work time, so dieback when the mangroves are, the rhizophora near to the channel is died because of salinization. Then coming to the, I already told the fish pond method, 2003 also they did fish pond. There is no growth, because they did everywhere. All the places they replanted, they did this one. See, 2003, they did 2015, the 17, there are, this places, this one, there is, even the salt pan also, they did the fish pond method. 3 and 2019, there is nothing is happened. So it's worked, but what they did before, some places they worked very good, and that's why they increased the mangrove here. But the forest department did all the places they did the restoration practice. That now is affecting the normal good mangrove also is affecting. That's 2003, 2011, even 2019. They're not successful also. That places they planted fish pond, they planted not successful also that region. So the natural colonization is good. If you conserve the place, if you give the place to that one, that is enough. That's just restoring the environmental conditions suitable for the regrowth survival may be faster natural mangrove recovery. This is our hypothesis one. Okay. Just this is also published in the remote sensing paper. It's available. This is published. Then last case study is Sri Lanka. One of our partner, Ruguna University, they did this one. Because this all the restoration will happen after it happened after the tsunami only. After the tsunami, there is lot of money in NGOs involved in this one. Lot of the entire international organization fund the money to the for this one. Even the Sri Lanka also after the tsunami only nearly 1,000 to 1,000 hectare mangrove restored here. But from government, non-government organization involved in this here, nearly 23 project sites and 67 planting places they did. So this is their results, their places. Now you can see nearly 9 out of 23 project sites, so no surveying plans. All in the zero level condition in this area. Only two in the 1,000 to 1,200 planted, but now the survey is 200 to 220 only the surveying is there. Survey is low with one. Only 4 sites, only above 50, the green color. This one only the now is surveying site. Other sites are not. Here also this, here we did the dry area, arid area, intermediate area also we work natural and planted seeding and survey seedings also, survey plant also, we did the analysis. Okay. So observation here, planting mangrove seedlings, incorrect topography and inappropriate soil condition. Same inappropriate species also. Then the then another problem here, cattle tramping, browsing, algal accumulation, insect attack also happened here in the areas planted. Then last one is the poor post replanting monitoring only. All the sites afterwards post monitoring is not well. Once their project is over, they just they went away. So the monitoring is not good. Okay, in this case, this is also published one, or they published actually. Afterwards, we taken all the from Asia and Africa area from the Google search, all the publications related restoration project related publication we collected, and then we checked here Africa in 35, nearly 198 project restoration paper we found, 35 in Africa and Asian countries. This is based on the different sources we taken for the restoration project. From the different years, from 90 onwards up to 2020, all the projects from both Africa and Asia, number of the projects, particularly in the 2008-9 time, the more projects happened in this one. Then survival rate also. Compared to the survival rate is less only. All the restoration project survival rate is less. Here what are the species they used for? Mostly they use 80% this one, rhizophora only they used for the planting purpose. So it's a general data. This is a potential benefit and potential problem. So the problem is larger project. Problem is they use the mono-specific plantings they used in appropriate biophysical conditions. Because there is no scientific research, nothing has happened. They just planted this one. That's why the survival rate is less only. So there is one paper recommended 10 steps we need to take care all the things. There is a degraded mangrove step by step up to monitoring level. After this is the 5 years. Then simple conclusion: the ecological social the area studied precisely before the taking the project. Then well-prepared managed mangrove restoration, good understanding hydrology and sedimentology of the places. Then to give more important replanting, species selection also, species selection, because what plant they get in nursery they having, then they planted. So we need to all scientific research purposes. Post-care to the successful restoration. The sustainable mangrove restoration requires investment in capacity building, communities and institutions. That's a must to this one. So this is just a chart of this one. Pre-plantation, plantation time, post-plantation. We need to take care of this one. Assessment of drivers. Assessment of drivers, land tenure, social support for the plantation, financial resource, then plantation time, native exact species, site selection, employment for the local community, then post-plantation monitoring, policy, documentation challenges all will be need to take care. Okay, this is already I told different project outputs. It's a European funded project, and then mostly European Union and French ANR project is funded this one. Thank you. Take home message, restoration is good, but we need to site selection and species appropriate only. Restoration is the good practice only. So we need to study all the things, then only we will start the restoration. That is the
Okay. Thank you very much, Doctor, for your excellent talk. We are going to continue with questions. ¿Alguna pregunta? Sí.
Yes, you have a reason for the tide conditions is important. How about with valley? In valley, the tide condition is too high, no?
Yeah.
What happened here in this place?
Valleys, in the birds, this is all our abundant, this one, aquaculture area. It's inside, not that much this one. Aquaculture, because aquaculture area, not too much tide area. It's a very intertidal zone only. All aquaculture already abundant now, because 90s there is too many aquaculture. The 19 is the boom everywhere in India also, Vaishak there, Kakinada area, too many, even our Tamil Nadu, all the places, Southeast Asia, there's a big economic, this one, that time, 90 to 2000, too many aquaculture started that time, aquaculture farms. Even mangrove area, all the wetland, even agricultural land, they destroyed, they made it this one. So it's not that much tidal area, it's the aquacultural area only. So now the aquaculture all abundant, because a lot of pesticide they use and this one, that places nothing is possible, they moved other places. So that places, now all the NGOs, all the organization, government taking the initiation to planting the mangroves, restoration that area.
Yes, thank you.
Thank you. In the fishbone project, part of the project, what was the criteria for the channels in the fishbone system?
I didn't get a fishbone?
Yes. You say about you talk about a fishbone project of
fishbone
restoration.
model, fishbone model. Actually, that structures look like a fishbone. They're just a burrow and ridge.
Okay.
So the ridge area, they make it the plant season. Burrow area, water will move.
What is the depth of the channels?
What?
You made some channels with
channels.
Yes,
Channels. That's why the fish bone method. The channels is the channel, the burrow area. Then the ridge area planted this one. That's a look like a fish pond.
Okay. No,
because there is no hydrological connectivity, there is no water in that area. That's why they make. There is no water. Nothing is so. They artificially making the hydrology. That's why with the normal area also, even Salpan area also they using from the water. Already is the backwater where is coming. From that they taking the digging the channels.
Okay.
That's
Sorry.
why no water is coming.
Thank you.
So this is not a restoration. Here is replanting. Afforestation is happening. Afforestation, new area, afforestation, new areas. Here, that's why replanting, restoration, then afforestation also.
Okay.
I didn't explain, I forgot to explain that.
¿Alguna otra pregunta? ¿No more? ¿No?
I hope enjoyed, I think. Not interested.
Doctora
The
Guíñiga.
question is not understood. Or after the lunch, I think all in the sleepy mood, I don't know.
Doctora Guíñiga.
I'll sleep.
It seems like very important to choose the ideal places.
Yeah.
And there is not enough effort to localize the ideal places to make successful the project. I mean, study the hydrology, the places
Yeah,
that
sir,
are.
even the Pichavaram also, that last one I showed in this one, there is successful places also is there. But what they did, they did all the places, there is a good success. If you take the restoration, the action is a good success only. But they, because of there is a more fund coming from the more funds, from Japan fund, all fund, the forest department, what they doing, wherever land is there, they converting, they restoring this one. That is the problem. Otherwise, good results is sold. Even that is one.
And in your opinion, this program, restoration programs must be continue?
Yeah, continue.
Because there is not a great results.
Yeah, it's, this restoration program is continuing. Now is the Indian government also, for the Indian constant, Indian government also announced everywhere they plan to plant the mangrove, they're telling. So they
I mean, in the context of climate change, probably the scales are different of successful and the impact of the climate change.
Yeah, that's why in climate change purpose only they plan to bioshield program, because to protect from the storm surge, cyclone, they want to the bioshield program to promote the mangrove area, to plant the mangrove area in this one region.
Thank you very much.
I have a question about the species, about your mangrove communities,
Yeah.
because you mentioned that you tried with different techniques, but I have my question is, where is the success? When you only use one species like Rhizophora mangle, or when you use like a different community of mangroves?
First I am clear telling, we didn't trade. It's already did by the different government or NGO. They did. We did the only research analysis, evaluation, how the effectiveness of the restoration we did. Because first in the Philippines also, the funded by the French agency, implemented by the one NGO in the Philippines, they planted. We went only for the their evaluation purpose only. All the studies we did the evaluation only. All done by the local only, local NGOs or government did all the things. Even the Pichavaram, government doing. But they doing all, they don't, not that much scientific is one. They have they whatever species getting, they will planting there. Not that much, yeah.
¿Alguna otra pregunta? ¿No? Si no hay más preguntas, sí, adelante.
Thank you for your presentation, Doctor. And my question is about the challenge with the communities, because I think this is a great effort to conserve and maintain the ecosystems, particularly these habitats that help us to other events, no, climate change, or waves, etc. And what is the challenge with the community to accept these activities, no? Because sometimes in Mexico it's very complicated to do sensitive to the communities, no? Sometimes, but in your cases, what are that changes and challenges? Sorry, and what have you done to?
Yeah, good. I got it. Actually, the restoration, if it coming to the restoration, if you use the community-based one only, it's surveying is good. Community-based, community gives the awareness, all this one. If you take the Pichavaran case, community involved. Previously, is a community, and there is a one foundation, one organization, NGO, involved community in basis only. Now is totally communities separated from the, because they announce, they declare the reserve forest. Nothing is, they not possible to enter in this one. They not collected any wood or nothing is possible. So community is separated. So if it community joint management only, it's a good one. That is because all the papers, many papers is telling is one joint management with the community and government, all this one, and then only the good is one. Without community to restoration, it's not good.
Muy bien, si no hay más preguntas, entonces continuamos. Thank you very much for your excellent contribution, and thank you for sharing your experience on this excellent theme. Now, I'm going to read your diploma. National Polytechnic Institute, 5th International Conference of Environmental Research Group, IPN, CIIEMAD 23, Our Planet and Our Future. This is to certify that Dr. Muthusankar has participated and present an invited lecture on a review of the effectiveness of some Asian mangrove restoration initiatives organized by the Environmental Network Research Group, REMA IP in Dr. Diana Cecilia Escobedo Urias and Dr. Jonathan Muthusankar. Thank you very much.
Thank you.
And 2 presents for you.
Thank you very much.
Muchísimas gracias a todos. Continuamos con el programa.